All right, y'all. Okay, cool. Here is our warm up. We are finding volumes, okay? And if you don't know your volume figures, you can definitely look those up. They're all over the internet. Lots of formulas out there for every shape. The first one is a rectangular prism. How do we find the volume of a rectangular prism? That's right. Length times width times height. It doesn't really matter who's who, so if you choose to do yours differently than me, that's okay because we're multiplying. 20 times 6 times 8, but it doesn't matter if you did it in a different order, it's going to be the same. So what is the volume of this prism? What is it? 960. And then that's centimeters cubed. Remember that volume is cubed. Okay, what about a triangular prism? Did y'all look this one up? I don't know if I know this. Let's see. I think it's 1/3. Volume. Of a triangular prism is, that's how to get the answer. I don't want the answer. I want the formula. Okay, this one is 1/2. I was wrong. Not 1/3, 1/2. The, what is A times B times C? Oh yeah, it's length times width times height. Okay, so you're still doing the same thing as the rectangle. You're just taking half of that. So it's 1/2 the length, which we can say is 12, the width, which we can say is 12, and the height does have to run from the base up to the peak, which is why it's got that dashed line showing that it's going straight from the base all the way to the very tip top of that prism. So 12 times 12 times 10, we need half of that. So what is that? 720? Thank you. Meters cubed. Okay, with a cone, is the cone the 1/3? Somebody's 1/3. Do I have a thing up here that says volume? No. Yeah, this is the one that's 1/3. 1/3 pi, height, radius squared. I think I would probably say pi r squared times height. Yeah, that's what this one says. So like I said, I mean, I'm just pulling it up on the internet and there's like lots of them to choose from. Okay, so if we look at this, we've got pi, radius squared, and height times 1/3. So what's the radius? 7. So that's 7 squared times the height, which is 24. So the hardest part of this, like if this was on your ACT, the hardest part's going to be knowing those formulas. Other than that, it's just typing it in your calculator. I'm just going to do pi times 7 squared times 24, and then I'm going to divide that by 3. So that would be 1,231.5 inches cubed. And that's an approximate answer. I did have to divide. I mean, not divide, round, but of course you did because you're multiplying by pi. Pi is always going to have decimals that go, 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 go. So, oh yes, thank you, Lake. Thank you. Okay, and then the last one is a sphere, like a basketball or a soccer ball or whatever. That's not a football. And it is 4/3 pi r to the third. Did y'all do these back in middle school? You had to. I don't teach this. It has to be somewhere that you learn it, though. Well, I teach you trig. I don't know. Anyways, okay, 4/3 pi on the ACT, you will. What's the radius? 4 to the third power. And like, I mean, it just depends on your job if you would use something like this. For the ACT, like on your midterm and stuff, like I would give you a formula chart if you needed one, but not on the ACT. Not on the EOC does give you a formula chart, but I don't think this is on there. I don't. The finals.
This can be like our finals.
This is just like something you're supposed to already know how to do. Like, this is not something that I'm teaching you. All right, there's that one. Okay, so like I said, I don't know exactly when that was taught to you, but it's definitely something that at some point maybe you learned, maybe you just don't remember. I don't know. It's not something that I teach you. Okay, we are still working on triangles. You have your triangle test, not a quiz, test, 100-point test this Thursday in class. Okay, so today's activity is really just a practice. We've gone over each of the ways. You have your reference sheet. You're probably going to want that today. So find that reference sheet, get your reference sheet out, because that's going to be what guides you through this lesson. You don't have one of those? Okay, I'll get you one. You cold? You cold? I think that's two. Yep. I was like, it feels too much. Just green beans. All right, so get that paper out. Let me grab her a reference sheet and myself a reference sheet. Hey, girls, y'all help her get all the tick marks that she's going to need from those. Okay. So this is going to be a day that you're going to get to practice. I'll be kind of floating around as needed, but let's look at it so you can see what's going on. Okay, so look how cute they are with their like SSS, SAS, ASA, AAS, HL, oh my, like lions, tigers, and bears, oh my. Isn't that cute? So cute. So that's all 5 types. Okay, that's how you will prove those. So on your Friday virtual day, that was a teaching day for us. You have to watch that video or you are going to be lost, because that's when I taught you about angle, side, angle, and angle, angle, side, and hypotenuse, leg. Okay, so that's what we did Friday on our virtual day. So if you just like copied someone's notes just to get that done, like you're going to want to go back and watch that video, because that's really the only day I'm going to teach you about that. Okay. So these are 12 different situations. The directions say compare the triangles and determine whether they can be proven congruent if possible by side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Then write your answer in the box. So you don't have to go through the fact of like proving it. You just have to look at it and see like, what do you know? How would you prove it? So let's look at number 6. If I look at number 6, they obviously look like they are congruent. They all look like they are congruent, okay? But you have to be able to prove it using one of those 5 things. Now, hypotenuse, leg is only acceptable if you have a right angle. So if not, then you only have 4 options. So this one obviously is not a right triangle, so I don't have that hypotenuse, leg option. I can only pick from the other 4. It does say that they're parallel. Remember that anytime they're parallel, you should be thinking about these 3 things, okay? Alternate interior angles, alternate exterior angles, and corresponding angles. So if we look at this, these are my parallel lines, and you can even extend it out some if it helps you to see that. Going. It's not really a great extension, but you're extending those lines out. They're being cut by this transversal. This is the transversal that's cutting them. So you can see that being cut. Yeah. The one that's going the other way, the one that's cutting them apart. So sometimes it helps to like draw it out separately. Let me see if I have a sheet of paper. So, and remember, a transversal has to go through both of them. Yeah. Do what? Yeah. Well, and they can all be transversals. Like, it can have more than one transversal line. So, like, if I'm going to sketch this out, okay, these are my parallel lines, okay? So I just drew these parallel lines. So he's exactly right in the fact that we've got more than one transversal line, because like you've got this one that runs up and down. That's one of the transversal lines. Then you have another one that's going this way. Okay, that would be a transversal line. But you could also have this one down here, but that would be a stretch because you'd have to keep going this way to get that one. Okay, so there are lots of different situations. What we already know, though, is that these angles and these sides are going to be congruent. So we have an angle and a side. So if you look at your options, that eliminates the first and the last. So you only have the 3 middle ones that it could be: side, angle, 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 side. So those are our options. We need to determine what else we know. If they're parallel, usually you're able to determine another angle, okay, based on one of these situations. So if I look at that, I'm thinking about this angle here and this angle here, because that would give me angle, included side, angle, okay? But if we look at those two angles, here and here, what are those two angles? Do they have a relationship? They're corresponding. Are corresponding angles congruent? Yes. Okay, and you can see that right here. Corresponding angles are a reason why they would be congruent. So that means this and this is going to be congruent. Now, when you look at what you know angle, included side, angle. So this is ASA. That's what you're trying to do. Okay, so I'm going to give you a few minutes to work on this. Talk with the people at your table. Y'all chat it out. See if you can come up with reasons why. Then the ones that y'all are stuck on, I will go over those here. If you finish and your table rocks it, then flip it over. You've got a bunch of proofs that you can practice with. Do you want to jump into a table? You can if you want. Okay. Yep. Yes. Yes. Do what? Oh, yeah. We're definitely going to check them. Are you almost done? All right, let's check and see where y'all are at. Let's look at the first one. Number 1. Is that one congruent? How do you know? ASA, because you know this side in the middle, the reflexive property. So that's angle, side, angle. What about number 2? Side, side, side. That's right, because you know this is shared, so that's going to be your third side. What about number 3? What is it? That's right, because you've got angle, angle, and then the non-included side. So that's angle, angle, side. What about number 4? Good, that's the hypotenuse leg. So this shared side is your hypotenuse, and then you also know a leg. So hypotenuse leg. What about number 5? This one's not congruent. You do know that these are congruent, but there's no such thing as side, side, angle, or angle, side, side. This is the one that's like supposed to make you laugh, okay? That's not possible, so that means that they're not congruent, okay? And like, you don't know anything about the other angles. We can't assume that this angle is congruent. We don't know if these are parallel lines, so you can't do anything about that. So there's just not enough information. Are they congruent? Maybe, but we don't have enough information, therefore we just say not congruent. Okay, what about number 7? Okay, this is the side here, so SAS. It's the included angle, SAS. All right, what about this? Side, side, side. Okay, that's the shared side. They include that together. What about number 9? Good. And like, I kind of got myself caught in the vertical angles, and I was like trying to look at this angle in congruence with that angle. And then I was like, well, that's angle, side, side. But this is a special case because we have the right angle, then we can do hypotenuse leg. Okay, so make sure you're looking for that because I kind of got lost. Number 10, what is this one? Yes, because you know your vertical angles. Remember, those are vertical, the ones that touch on the nose. So angle, angle, opposite side. Angle, angle, opposite side. What about number 11? Well, you don't have enough information. You know that this side is congruent to that side. You know that angle is congruent to that angle, but that's it. You don't have enough information, so we just say not congruent. Even though they look like it, they probably are, but they didn't give us enough information, so you can't assume. Now, what about number 12? SAS. Okay, well, how did you prove the A? Well, okay, you use this one. Not corresponding. Alternate interior angles. You are right, okay? This angle and this angle are going to be congruent, the green ones. And so that gives you side, included angle, side. So that's side, angle, side. But somebody said something about the vertical angles, and they're correct too. These are vertical angles, these pink ones. If you look at it in terms of that, you also have angle, side, angle. So you could do angle, side, angle and prove congruency that way and just not use these sides over here. Okay. No, as long as you like picked one of those, if it was like an answer like this, that would be totally fine. And if it was a proof, you would just have to prove it based on what you decided. Okay. So now let's flip over and look at the proofs. These will be on your test, you guys, but just like on your quiz, I've filled in this side. I've filled in the statements for you. What you'll do is you'll fill in the reason. So just like the ones on your quizzes, just because for grading purposes, like we just came up with 2 potential options, I want it to go a certain way so that it grades it accurately. So that's why I did that. I also, while I'm thinking about this is totally off topic, but very important. When I release your quizzes to you guys, y'all realize that there's like 140 students, that I have 140 students. I'm not going to go through all of those tests and see if you misspelled the word isosceles. But because it's on a computer and the computer's the one grading it, if you misspell isosceles or congruent or something, you make some silly mistake, it's going to mark it wrong. So you need to, every time I release the test back to you, you need to go and look at your score. Even if you made like a 34 out of 35 and you only missed one, you could have missed that one because of misspelling. Okay, now I cannot spell to save my life, so I would never take your points off for spelling. Okay, that's not that important to me, but I'm not going to go look for it. Okay, you have to go and look for it. There are some of them I know that I have to self-grade, and I will go in and make adjustments, but I'm not going to go look at spelling. Okay, so when I release things to you, make sure you take a second to go and look, like, did you misspell something or make a silly mistake that the computer is going to count off on? All you have to do is show it to me, tell me, and I'll fix that for you, okay? So just for the rest of the year, anytime that happens, y'all go in and check that stuff. I haven't released the last one to you, but I wanted to tell you that because I probably will today. There's a couple people I'm waiting on. When I release that one to you, you'll definitely want to go check it because of the proofs. So like if you misspell the word given, like they're going to mark it wrong. So you've got to make sure that you check that to make sure that you don't get your points taken from you when you should have actually gotten those points. Okay, that's just sidetracked. I was just thinking about that. All right, so let's look at this. This is mixed up. So it could be any of them. Okay, it doesn't necessarily have to be side, side, side or side, angle, side. What they tell us is that L is the midpoint of both of those sides. So if L is the midpoint, let's not think about the proof yet. Let's just think about what we know mathematically. If L is the midpoint of KN, then what's that tell us? Let's just focus on KN right now. So like just KN. If L is the midpoint of KN, what do you know? That's right. KL and LN are congruent. You know that because of the midpoint. Now, if you know about MP, L is the midpoint of MP, then what do you know based on that? That's right. You know that those are congruent. What else do you know based on this situation? Your vertical angles. Is that enough information to prove that those two triangles are congruent? Based on what? Side angle side. So you just did that proof. Now we just have to write it out. Okay. So what's our first statement going to be? That's right. L is the midpoint of KN and MP. So that would be on there for you. You don't have to write that out. What you have to write out is the word given. And I turned off the case sensitivity. So if you do capital G, lowercase g, that's not going to count it wrong. But if you forget the I or something weird, like it would count it wrong. Okay, so just go in and check those things. Now, what would we list next? What would be number 2? Yeah, and you could kind of pick wherever you wanted to go, which is why I did this part for you, because you could go different places. We're going to say KL is congruent to LN. And how do you know that? Definition of midpoint. Okay, where would you go next? ML is congruent to PL. That is also the definition of midpoint. I don't think I wrote definition on there this time. Actually, I'm almost 100% sure. So when you do it, you need to write out the word definition. Don't write DEF, okay, to mark it wrong. Write out definition of whatever it is, just like it says on your reference sheet, okay? What's number 4? Okay, angle MLK is congruent to, is it P? Yeah, PLN. How do you know that? Vertical angles. What's the last thing on here that we do? That's right. And then how do you know? Side angle side. All right, these 5, 2 through 6 are your homework. You've got 10 minutes that you can work on them in class, okay? If you get done with these in class, then you don't have any homework tonight. You do need to submit this to me, this page, okay? First page, for my in-class people, you don't have to submit. My virtual learners, you need to submit the first page and this page. Through all of them, 5 through 6. So 2 through 6, the rest of the page. Hey, and do it together. You've got people at your table. Y'all talk about it. Yeah. Let me end our Zoom meeting.